So to begin solving this problem, there's a few things we need to observe. We first need to set up the initial value problem, or the IVP. Okay, and this requires us to get M and K. Okay, so we can obtain these. First of all, we are not working with the metric system, right? Feet per second refers to the imperial system, right? And again, you see feet here and you see pounds up here. So we're using the imperial system. So how do you get mass from the imperial system? Well, we recall the definition we had for weight, which was mg, right? So this is going to imply that m equals weight divided by g. And so this further implies, since we're using the imperial system, that m is actually going to equal 16, right? And where does 16 come from? You probably noticed it came from our initial situation, right? A 16-pound object stretches a spring. So it's a 16-pound object, and this is being divided by 32, right? Feet per second squared. So the mass of this spring, the mass that we're looking for is going to be 16. Oh, sorry, again, another mistake. Just going to be 1/2, right? There we go. So now that we have the mass, we're going to now obtain K. Okay? So to obtain K, we have to use this fact, that mg equals K times L. Okay? Also, I don't want you to forget that all of our length units are the same, and we'll use feet for the unit of measurement for this problem. Okay? And that was based off the conditions we were given at the beginning. So altogether, this means that K is going to equal mg divided by L. Okay? And so mg refers to the weight, so this will be 16, and L refers to the length of our spring. That was 8/9. And when you solve this, this becomes 18. Okay? So K is equal to 18. So now we can set up the IVP. We can now set up the initial value problem that we're going to solve. Okay? That will be 1/2, and you know where we got that from, don't you? That was m. And this is based off of that original equation we saw and derived previously. So what we have here is going to be 1/2 u prime, and remember this is based off a free undamped motion, plus 18, which was k, times u, is all set equal to 0, right? But that's not all. U of 0 is going to be equal to minus 1 over 2. And U prime not of 0, excuse me, is going to be equal to 1. Okay? And so for the initial conditions, I want you to recall that upward displacement or motion is negative, while downward displacement or motion is positive. Also, since we decided to do everything in feet, we had to convert the initial displacement to feet. I want you to keep that in mind. So now to solve this, we can either go through the characteristic equation, or we can do something simple and just jump straight to the formula that we derived previously. And that's the way we're going to do it. So first we need the natural frequency, which was omega naught. And that equals the square root of 18 divided by 1 over 2. Okay? And so that equals the square root of 36, which is simply going to equal 6. Okay? So therefore, the general solution, along with its derivative, will take the following form. U of t is going to equal C1 times the cosine of 6t, okay, plus C2 sine of 6t, okay, and U prime of t is then going to equal negative 6 C1 sine of 6t, okay, plus 6 times C2 cosine of 6t. Okay, and we'll revisit these two shortly. All right, and how short is short enough? How about right now? So we're going to be applying the initial conditions to get minus 1/2, which equals U of 0, and this happens to equal C1, right? So very clearly C1 is then equal to negative 1 over 2. All right, and again, even the initial conditions, all of these were taken from our previous derivation. And likewise, 1 is going to equal U prime of 0, which then has to equal 6 times C2 times the cosine of 6t. Okay, and so this implies, when everything is said and done, that C2 is going to equal 1 over 6. Okay, so now the displacement the displacement at any time t okay, is then u of t, which equals -1/2 times the cosine of 6t, okay, plus 1/6 times sine of 6t, okay? And in our next video, now that we have the displacement any given time t, we are going to then solve for r, the amplitude, and for delta, which is the phase shift, and then proceed to graph our solution. Stay tuned.